Thank you for coming to our booth. We're going to do an activity with you today where we take sun paper. And you may have seen sun paper at a local craft store. It's very common use. A lot of Boy Scouts and Girl Scouts end up using this. And what this does is it reacts with sunlight. And it reacts with a special portion of the sunlight. Not the sunlight that we can see. It reacts with the UV light from the sun. And the UV light in the sun is what makes you tan or gives you a sunburn if you spend too much time outside. And what we have is we have special lights we're going to use with you today called UV LEDs. And we're going to use those UV LEDs to write on this sun paper. Typically when you use this sun paper, you'll put an object on it and take it outside, and that object will be covering the portion of the paper that's not going to react with the light, and the remaining portions of the paper will react. We're going to do something slightly different by using our UV LED. With our UV LED, we're going to write directly onto the paper itself. And so we're going to change only that portion of the paper. So what I have here is a UV LED. LED stands for light emitting diode. And we're going to take this and put this directly on our piece of sun print paper. So first thing we're going to do is we're going to take our LED and we're going to press directly onto the sun print paper. Be sure not to press too hard onto the paper. We don't want to break the soldering of the LED. We're going to hold it here for a couple of seconds, and then we're going to lift that up, and hopefully what we'll see is a white print from where that light was hitting the paper. If we look closely, we will see that. It's going to take a couple seconds to do that. What we're going to do now is we're going to drag the LED along the paper, starting at the dot that we've just made. What this will allow us to do is to draw a line. And we're going to draw that line until we see, we're going to keep moving this back and forth until we see a line of this white area. Before we can give this to you to take home, we need to make this image permanent. And we do that by placing this in water. If we didn't make this image permanent, when we went outside, the whole paper would turn to this white color. By placing this in water, what it's going to do is it's going to change the white portion to a darker blue, and it's going to change the white portion to a darker blue, and the surrounding portion will get lighter. We'll now take this out from the water, and this is for you to take home. This is the image that you've made. We can also do some other interesting activities with these UV LEDs. Something else you may be familiar with are called UV beads. These are beads that when you go outside will change colors due to an interaction with the UV light, very similar to the paper. These, when they're indoors, will go back to white, but in the presence of the sunlight will go to different colors. Different kinds of UV beads here. One of the things that's interesting about an LED is that it only gives off light in a small range of wavelengths. The sun will give off UV light in many different wavelengths. And each wavelength has a different associated energy with it. The UV LED here, because it's an LED and because of the way it's made, gives off a shorter wavelength and gives off a shorter range of wavelengths and will only give off a certain amount of energy. These beads, the different colors of these beads require different types of energy to make the changes. So I'm going to take this UV LED and put it onto these two beads here. And hopefully you'll be able to see what's occurring here with the UV light. You started off white, and hopefully what you'll see is that these are turning purple. If we try to change these two beads here, they don't change as easily. The amount of energy that's coming off from this UV LED is enough to change the beads that are purple, but not these two beads here, which will turn a different color. One last activity we're going to do with you today is for you to be able to look at the spectrum of a UV light. A special instrument that chemists use is called a spectroscope. And a spectroscope will allow you to take the light that you see and break it down into its individual wavelengths. And that's done by using something called a grating. And in this case, we have a piece of plastic grating. So if we look at a light, what we will see is it'll break it down into its individual colors. You may or may not be aware, but the white light that we see from light bulbs is actually made up of multiple colors of light. How many of you have seen a rainbow? Well, a rainbow is produced in the same way, except instead of having a grating, a drop of water will be used to separate the light. So when you see a rainbow, it's taking the light from the sun that goes through a drop of water and separates it into its individual colors. This grating will do the same thing. if you've seen this activity before, you may have seen it called rainbow in a box, because that's what we'll be able to produce. You'll be able to look through this box at a regular light bulb and see a rainbow. The way you're going to use the box is we have two openings. We have a small slit on one side, and we have a portion with a grating on another. We want you to hold the grating up to your eye and then look at a light. We want you to position the slit such that you see the light coming into the slit and look off to your right. And what you should see, if you look at a regular light bulb, is a rainbow. What we're going to have you do is we're going to have you look at different types of lights. We have a regular light bulb in the form of a flashlight that you can purchase. We're going to have you hold that up to the slit and then look through the grating. And what you see is that by looking through this, you're going to see a rainbow where we have all of our wavelengths in a long strip, and there's no space between them. So you go from one color into the next as a rainbow would be in the sky. I'm going to now hand you all a piece of paper. And on that piece of paper is going to be the spectrum that you see from a regular light bulb. This is a spectrum you should see through the spectroscope. Now what I want you to do is to look at the different flashlights with the different LEDs and start to draw the spectrum that you see from those different LEDs in the spaces provided. So now I'm going to turn on some lights made of LEDs. I have a red flashlight made with red LEDs. I want you to take the box and look at the spectrum that is given off from the red LEDs. What do you see? I hope that you saw that we're only going to see lines in the red area of our spectrum, because this red LED only gives off light in the red region. So it only gives off a small set of wavelengths of light, all situated around red. Now we're going to have you look at a green LED. So through the box, what looks different to you? Do you notice with the green LED that there's more than just green light given off by this LED? That's what you should see, but you should also notice that it's not a complete set of colors that are given off like it would from a regular light bulb. The green LED gets its color from having different wavelengths of light combining to give a green color. Now we're going to look at a white LED. You might be interested in what this looks like, and is this different than that of a regular incandescent bulb? And what you'll find is it's not that different. People always ask what it is that causes us to see the spectrum inside the box. It's actually all the work of just the diffraction grating. If we look inside this box, if we open this up, what we'll see is there's actually nothing inside the box. It's just the light that goes through the slit and hits the diffraction grating. When we see the image, we happen to see it along the back of the box. But there's nothing inside the box itself that causes this image to be formed. You're probably wondering what makes LEDs special and why we would want to use them. We have lots of different types of light bulbs out there. We have fluorescent light bulbs and we have incandescent light bulbs. Those are the normal light bulbs that you see. One of the things that is really great about LEDs is that they're a lot more efficient. And by efficient, I mean they take less energy. And as we know, with the way things are, we really are concerned with the amount of energy that we use on a daily basis. LEDs, one of the things that they're a lot more efficient because they don't give off heat. So the energy that goes into producing the light will give off light rather than light and heat. A regular light bulb, as you know, if you try to put your hand on it after it's been on, it's hot because they're not that efficient. They don't give off all the energy that goes into that light bulb as just light. Some of it is also produced as heat. So if you look at one of these LEDs, we can turn this on and we can feel the LED. It's not going to get hot. It stays the same temperature. And that is because, as we said, they're a lot more efficient. So where are places where these LEDs are used? They're used very often in traffic lights. So if you look at traffic lights, you'll see individual dots. And those individual dots are individual LEDs. So you'll have green LEDs, red LEDs, and yellow LEDs. And some of the advantages of using these in traffic lights are, one, that they're a lot more efficient, so it takes less energy to use the traffic light. Second, that they don't die out like a regular light bulb. They start to get dimmer and dimmer. And because these are individual bulbs within, a lot of small individual bulbs within a traffic light, if one or two goes out, the traffic light will still work. So over time, it means that they don't need to do as much work on a traffic light, and they can save money in that way.